Hello, everybody. Let's do some solutions. I'll just program through all four problems. So problem one is using JOption pane or scanner, and you can choose which one you want to do. Get user input for the radius of a circle, and then compute and display the circumference and area. So here I've got an empty main. Let's do this. So string response is JOption pane show input dialog. And how you actually remember to do this is in the notes, and you could totally print out the notes and use them as reference. It's totally okay to use references. So enter a radius. And remember, JOption pane always returns a string. So to create a double, you have to parse it as double. So I'm going to call this radius, and we'll say double dot parse double response. If you wanted to, you don't actually need to save the string. You could go ahead and put that directly nested in there, like this. Yeah, let's try and make that display better. A little bit shorter, a little bit nicer. All right, so now that we've got the radius, which I'm actually going to spell out fully as radius, let's compute the other things that we're trying to compute. So I'll have double area is, let's see, it's pi r squared. So I'll use math.pi times radius. Notice I'm using tab completion there. And then circumference, which I don't know how to spell, so I'll say circum, is going to be 2 times math.pi times radius. All right, and then we're going to display them. I think it's nice to display all in one line. So for a circle with radius, let's do this. Has area, and circumference. All right. And we always want to run it to make sure it works. So I'm running it. You'll see it's building down here in the lower right. All right, and our radius is 3. And this is a circle with radius 3, has area this and circumference that. And we could double check to make sure that was right. Okay, for problem 2, we're supposed to use Heron's formula to compute the area of a triangle. So here's Heron's formula. It's the square root of s times this other stuff. But then s is defined as this thing over here, the semi-perimeter of a triangle where a, b, and c are the side lengths. All right, so it's a little bit complicated. That was on purpose. You've got to think it through. We're supposed to write a static method that takes 3 doubles as parameters, a, b, and c representing the side lengths. So let's go ahead and start to do that. I didn't say what the name, all right, so let's back up. So I didn't say what the name of the method should be, so that means it's up to you. You could start creating the method here outside of main. So you could say public static, it's going to return a double. Let's call it like triangle area, like this. Or if you're programming by intention, you could use the method the way that you want it to be used. So let's do triangle area, and I'll give it 3 values for the side lengths, and then you can hit Alt-Enter to create the method. So double, oops, I want this actually to be a double A, double B, double C. All right, so there's triangle area. Let's go back and look at the equation. So this is the area, but to calculate the area, I need this s, which is a plus b plus c divided by 2. So let's compute that first. So here I'll say double s equals a plus b plus c over 2. And then let's see the equation. I'm looking at it on my other screen here, so I'm going to return, well, let's compute it first. So double answer equals math.square root of s times s minus a times s minus b times s minus c. All right, great. And then we could say return answer. That's actually a little bit silly because I don't need to store the answer into a variable if all I'm doing is returning it. So I could do that. And if you wanted to, you could embed this expression every single time it appears in S, but I think in my mind that would make the expression too complicated to look at. This is a lot easier to look at and therefore think about. So my favored solution is this one. Okay, great. So we've written our method. Let's see, write a main method which tests it on 3 different inputs. Okay, so here I'm testing it on 1 input. And rather than save, I would want to like look at it. So I could say display area here. Rather than do that, I think what I'm going to do is I'm just going to display the output directly. So I'm going to embed the method call here right inside print line. So it will evaluate this first, and I'll just display the outcome. And so we can just have like a couple of different triangle lengths. And then this one could be like 4, 4, 4. And we can run it. Whoops. Right in debug mode by accident. It's okay. That's what happens when you run it in debug mode. Okay, interesting. So this is why, come on. All right, so this is why you try and debug things. So here I'm getting 6 and then NaN and then 6.928. So what is this NaN about? What I've done here is I've actually given side lengths that don't make a triangle. If you imagine actually trying to draw a triangle on a piece of paper with these side lengths, 8 is so large that if I have side lengths 1 and 2, these actually aren't large enough to connect to each other if they're both attached to a side length of 8. So the reason I'm getting NaN, which stands for not a number, is because these don't make a valid triangle, and then in the actual calculation, I'm actually ending up taking the square root of a negative value. So let's try this again, like with 3. Let's actually do it with like 2.54. Okay, so one more time. All right, great. So that seems more reasonable. Let's go on to problem 3. Okay, in this problem, it's about wind chill. So given a temperature in Fahrenheit and a wind speed in miles per hour, so T and V, we've got this equation that determines like the effective temperature, which is the same thing as wind chill. So I see some T's in there and I see the V in there, and I'm noticing it's V to the 0.16. So we're going to have to use the math library to do that exponent. So the formula is only valid if the temperature is between -15 and 50, and if wind speed is larger than 3 or less than 120. Let's write a program to do it. Okay, and so here I'm giving you the method signature. So let's go ahead and do that. So I've pasted it in here. I guess I'll leave main empty for the moment. Let's go back and look at the equation real quick. So actually here I'm going to put it on my other screen and then type along as I'm looking. So I think I can just directly return what I want. So I've got 35.74 plus 0.6215 times temp. Because even though in the equation it says T, my actual parameter is named temp. And then plus 0.4275 times temp plus minus 35.75, and then times, and now I want to do V to the power of 0.16, and this is going to work, except instead of V, we've got wind speed. And in some programming languages, this is how you do exponents, not in Java. So we have to do math dot, what was it? So we've got math.pow. So math.pow AB raises a to the power of b. And so what I want to do is I want to raise wind speed to the power of, let's find my equation again, 0.16. 0.16. Great. And I think that's it. It's just that one line. Okay, so what happens if I give it a temperature or wind speed that's outside the valid range? Oh, you know what? So if you actually watch those videos that I recommended that you watch, I talked about JavaDoc comments. So let's just do them because it's a nice practice. So / ****, and you hit enter, and it will fill in all this stuff. This @param stands for parameter, and you see that we've got temp and wind speed as the two parameters. And so you can tell it what the parameters are. So this is like ambient temperature in degrees F, and this is wind speed, which is wind speed in miles per hour, and then return the effective temperature, wind chill. And so then at the top, we say sort of like, what is the method doing? So returns the wind chill given an ambient temperature and wind speed. Sometimes it's helpful to write preconditions. Preconditions are assumptions that we want to say need to be true in order for this method to do what we claim. So on the AP exam, you would see something that looks like this, precondition, and then you state what I said, like what has to be true for the method to run. So you'd say temp. Well, typically you do something like this. Well, wait, hold on. I forget what the preconditions were. Let me check them. It says between -50 and 50. So I'd say -50 less than or equal to temp less than or equal to 50, and wind speed is between 3 and 120. 3 less than or equal to wind speed, less than or equal to 120. So here I'm saying temp is between these, wind speed is between those. And that's okay. There's a slightly more professional thing that you can do if you know about exception handling, which is you can do something like this. You can have @throws. So I'm saying I'm about to throw an exception. And then you tell it what type of exception. So illegal argument exception. And then I can say if, and then I can give the description here. But then if I did this, I would actually want to throw the exception. But since we don't know about exception handling, I'm not going to give that example. Okay, so now in part C of the problem, it's saying create a main method where you can test it, use JOption Painter Scanner to prompt the user for a temperature and a wind speed, and then pass those as arguments. So let's do that. So here I'll say temp equals double.parse double, and then JOption pane show input dialog, null, type a temperature, and then I'll do the same thing for wind speed. Type a wind speed. And it would probably be nice to tell them the valid range. So between -50 and 50, and then type a wind speed between 3 and 120. All right. And then let's run our method. So wind chill equals wind chill, and then temp wind speed. Great. And then we'll display it. What is it not like here? Method call expected. I am using a method call. Oh, it's called wind chill. My mistake. Okay. And then it would be nice to display, a nice output for the user. So with a temperature of temp and a wind speed of wind speed. Wind chill is wind chill. All right, and so we can test this, make sure it works. Wait, am I running it? Oh, yes, great. All right, so temperature of 30 degrees with a wind speed of 20 miles an hour. And it says wind chill is 17 degrees. Great. So if we wanted to make this a little bit nicer, we could do something like actually test the conditions. So we could say if it's not the case that temperature is between, negative 50 and 50, or let's actually do it this way. So if temperature is in the right range, and if wind chill is in the right range, if wind speed is in the right range, then we can do all this. Otherwise, we could say not valid. So we can do that. And if we wanted to, we could add in, well, all right, so let's do this one step at a time. So the problem here is if I said else not valid, if I type a valid temperature but not a valid wind speed, it actually won't do the else, so it won't display anything. And maybe we'll do this as a problem later on when we talk about if-else chains. So I could add this as like a second condition in a single if statement like this. So both of those things have to be true. And now this is like a little bit harder to read, maybe, but I could have an else statement where I say like not valid. Come on, computer, keep up. And that's okay. I think what's even better than that would be to use a loop where we keep asking them to type these things until they type a range that's valid. So I could say, let's use a do while loop for that. So I could say do, ask them to do these things, while it's not the case that we are typing some valid numbers. Oops. So here, I'll cut these. And like, you didn't have to do any of this stuff. I just wanted to show you, I think, what a nice solution would look like. Okay, a problem here, it says it doesn't know what temp and wind speed are because you have to actually declare them outside your loop. So temp and wind speed here. And now I don't want to redeclare them in the loop. I just want to assign them. All right, great. So now it will continually ask me for these two values until I enter a range. Until I enter a range that's valid. Okay, so that's problem 3. Problem 4 says write a program that will simulate rolling 2 6-sided die using math.random. Be careful that your random number is between 1 and 6. Watch this video if you need to, and then output something like that. How many times am I supposed to do it? Run it 20 times. Okay, great. So let's do that. So I'll start off by looping 20 times. So for I goes from 0 to 20. So now I'm sure I'm looping 20 times. Let's save our 2 die values. So I guess we could do this. So int math.random. So math.random gives me a value between 0 and 1, but not including 1. So if I multiply it by 6, now it's between 0 and like 5.99999. So if I add 1, now what used to be 0 to 5.9999 is 1 to 6.9999. So that's too big. So let's make it back to that. So that's die 1. Let's do die 2 is the same expression now. And S out, what am I supposed to be displaying? So die 1 is die 1, comma, die 2 is die 2, and then, whoa, their sum is, and then let's just add it right here in the print statement. All right, let's run it and see what we got. Okay, so I just want to double check to make sure I'm not getting values that are not between 1 and 6. So here I'm getting, for die 1, I'm getting 5s and 1s and 4s and so on. Interestingly, I never seem to be getting 6, so this is a sign to me that maybe I'm off by 1 in my calculation. So let's think the logic through again. So math.random can't be 1, which means that when I multiply it by 5, it can't be 5. It's always something smaller than 5. So when I add 1, now it's always something that's smaller than 6. But then when I truncate by casting to int, anything that's smaller than 6 is automatically going to round down to 5. So my logic was too quick. And that's pretty normal to be off by 1, and that's why we test things. So let's run it again. All right, great. So this is looking a lot better. So if this went a little bit fast for you and you're thinking, wait, why is there a +1? And like, what's this about the 6 and the truncation? Watch the video. Watch the original notes video on math.random, and it'll sort of remind you, hopefully, how all that works. All right, I think that's the end of the problem set. I hope that seeing the solutions was helpful. If it turns out that you didn't get one of these correct, or you did, but it was sort of convoluted, or you want to try it again, a really great exercise is to rewrite the method yourself from scratch without looking at an answer, because that's really going to help solidify it in your mind. And you're going to hear me say this like a dozen more times, several dozen more times during the year. Being able to type out a solution you've already thought your way through is a great way to have it become a basic building block in your mind that you can then use to build more complicated stuff. All right, good luck on the next problem set.